turn this on. Are you familiar with Ubuntu?
I've used it a bit, and I only installed a couple of programs, but I wasn't able to like customize it the way I wanted to, and then I eventually gave up on it and switched back to Windows.
Once you get used to it, it's not so bad. I still have a lot to learn about it, but it's a pretty robust program. Okay, so I'm going to take. See, for example, we have leftover boards here that people don't need, and actually you see there are areas here where I can actually go ahead and use them for some of these smaller boards. So that's what I'm going to do. I'm going to, well actually I'm not going to lay down, I don't really need a scavenge board. So I'm just going to, I try to get all the tape. We use some double-sided sticky tape here to hold the board down. And I'm going to remove what was there before, because actually, as sensitive as this machine is, you really want a nice flat surface. And if I had 2 layers of tape, that makes enough of a difference when you're running this mill across there. You'll see it'll show up in the end product.
Gotcha.
Even though this is scrap, there's quite a bit that we can still get quite a few of these smaller boards out of it, which is what we use in our inventory. Okay.
Yeah, it's definitely nice to see that things are being recycled as much as possible.
We recycle, yeah. And the advantage of the process that we use here, see, a lot of times people, when they're making circuit boards, they'll use an etching process, which uses all kinds of nasty chemicals, you know, which typically they're not supposed to. It ends up in the drain.
Oh, wow.
In the water supply. Not good. So this actually is nice because it produces a little dust, but basically it's just it's very environmentally friendly. Now it's not as efficient. You know, if you're making a lot of boards, you would want to go to a board house. But for, you know, since we're making just, you know, 1 or 10 boards at a time, it's perfectly acceptable. Okay, so I've got double-sided tape here. So I'm just going to lay that right on here. So you see somebody actually drilled into the bottom of the board.
Oh,
here.
no.
You don't want to do that. That's why you often will have a scavenge plate.
Okay.
But since I'm good, and since I'm not planning on going down very deep, I'm just going to mount it right directly to that. Okay. So the way to get into the lab here, Fab Lab. That's get you anywhere. Okay. Now what we're going to do is grab an internet connection, and I'm going to go exactly where I showed you before, which was to the Academy. I already know I go there all the time, so it knows that. Courses, I do that every time. Classes. Output devices. Okay, and I'm going to go to the traces. I'm just going to go ahead and save that. Let's see, save image as, and I'm going to save it to the desktop. Good. As a PNG.
Okay.
It's already the way I want it. Now I'll go up to my application menu and I'll open up the terminal.
Okay.
And I'm going to go ahead and change from the directory to the desktop. And then I'm going to just type fab, which brings up a set of utilities. It's a little GUI interface to what they call the fab modules.
Gotcha.
Which will take an image. And we can take that PNG image and send it to the Roland Medela. We can send it to the laser cutter. We can send it, well, G-code, which we could then bring to the 3D printer. A shop bot if we had one, but we're about $20,000 short for that.
I hear you on that.
A water jet cutter, we're about $100,000 short on that.
Ouch.
But anyway, typically we go to the Medela. So, okay, so I'm going to go from image to the Medela. And just click on that and up pops another GUI. And I'm just going to load the PNG. There it is. You can see that's that same file that we looked at. Now I'll go ahead and click on here. I'm going to mill the traces, and I'm going to use a 64th inch bit. And when I do that, it kind of populates these windows here with some predefined values. It turns out a 64th of an inch is about 4/10 of a millimeter.
Okay.
And you and I think in inches.
Yeah.
But you know, scientists like to go in metric.
Gotcha.
And computers like to go in pixels. But anyway, basically what the important thing here, other than the diameter of the bit, and we can accept these defaults here, we're basically saying we're going to follow this line 4 times. We're going to look for the boundary between black and white, and then follow that line. We're going to cut a path.
Okay.
And we're going to do that 4 times, although each time we cut the line, we're going to overlap slightly so that we're basically removing material so that we're left with traces.
Gotcha.
That's the thought there. So, and 4 turns out to be a pretty good number. So then I'll just go ahead and go with make path. And it makes the path, and there it is. You can kind of see how it's cutting everything away. And basically, all we want to do is cut enough away so that we're left with electrically conductive traces that we can then solder to.
Okay.
And make our circuits. And so now I'm going to go. Now we have to set up the drill bit here. So we'll get a 1/64th inch bit. Pull that out. That's it. 1/64th of an inch. Turn the machine on. I'll push the view button and that'll bring that forward a bit.
Okay.
Make sure this is down. And what I can do is I can set the position here so that I can make sure that it cuts over here or up there or whatever.
Gotcha.
So now I'm going to go ahead and insert this part way into the collar here. It actually has 2 set screws on either side. You always want to remember to tighten both of them because otherwise one of them flies out.
Oh wow.
And that's not good. But that holds it in pretty securely.
Okay.
And you can see now I'm going to go ahead and bring it down. And I'm just holding it down, and I'm not going to bring it all the way down to the board, but I want to try to bring it close. Okay, that's close enough. And I can see that I really want to start over here, 10, 20, 30. I'm going to move X, I'm going to go 30. And I think my Y, I'll go up 5. So let me move that. Yeah, actually I think I'm going to make that 35. And you can see that's kind of my start area. And typically we start here in the lower left and work our way over.
Gotcha.
So now I have that set, and now this is kind of the important part. Now I'm going to loosen these guys, and then very carefully I set this drill bit right on and contact the FRS1 there. And then while I'm still using my finger to hold the bit down, I'm kind of turning this thing here clockwise to tighten it. Not super tight, but good and snug. You don't want to strip the thread.
So you loosen the bit so that I could come down and actually make contact with the board?
Contact the board, yeah.
Okay.
And like that's It's very sensitive. That's why you want it to be flat, and that's why you don't want double layers of tape.
Oh, wow.
You see. Okay, so now we have that set, and the speed here, we can accept that. It's going to be moving at about 4 millimeters per second. It could theoretically move as fast as 15 millimeters per second, but we don't want to break the bit. It's a very narrow bit. So now we can go ahead and hit Make RML, and let me go ahead and get the safety shield up.
Oh, it's in my, sorry.
Oh, it's in your hand, okay.
Yeah.
And I'll set that here. And then I'll go ahead and hit send. And there it is. And then we can just leave this running. Like I say, it'll probably take 10 minutes,
okay.
Maybe less. But anyway, that's this is kind of like the cooking channel. And here it is. Okay, you see, we've done several. And I might do several here again. Since I already have this set up, and in there I can come back here when this is done, and I'll just move it over a little bit and have it cut out another board. Because again, we do a lot of these monkey boards. This is a very good introductory project.
Gotcha.
And actually, now there is a way you can take another drill bit here and cut out a nice, perfectly rectangular outline. Okay, that's the MIT way of doing it. But here in the East Central Illinois back of the tool shed way, we're just going to cut it out with a saw.
Ah, gotcha.
We are just across the road from the agricultural library. Okay. At least two of those cuts aren't too bad. But anyway, that's what we'll be working with.
Cool.
And actually now the final step is we're actually going to give this a little bit of a bath. And that's because the oils in our fingers will make it more difficult for the solder to
Oh.
She's got a spirit set up there. I'll just take a little bit of soap and water and then just rinse it off. Dry that off and you're about ready to go.
Awesome.
And that's your board, and that's what you're going to use to solder it up. So I think what we'll do in the meantime, let's go ahead and warm up some of the soldering irons here. Just turn that on. Somebody's really... What is the best for soldering? 770?
Oh yeah, around 750.
770, okay. Yeah, so we'll just set that there. Then also what we typically do, instead of tap water, we'll use a little bit of distilled water.
Oh, for
But since we're out of distilled water, we use tap water. Have you done much soldering?
I've done a little bit.
Okay.
Nothing serious though. Like a broken fuse or a busted fuse in a subwoofer.
Okay.
So we just like resoldered it back.
Okay. This is a little more refined. Like I say, they're very small parts. They'll be, takes a little getting used to, but you'll get the hang of it. So, get a piece of wood, or no, just a piece of cardboard.
Okay.